Good evening, everyone. Welcome to first LEPAK session of semester 2. Today we are going to explain about chapter 1 Electrostatics. So here I will show you the formula. You can pause and have a look at it. And next, here's the question. If you want to pause, yes, you can do so. And now I'm going to start explain about question 1. If you want to fast forward at the right bottom, you can do so in YouTube. So 1a. A negative 4 charge lies on a straight line between a 5 microcoulomb charge and a 2 microcoulomb charge. The separation between the 5 microcoulomb charge and 2 microcoulomb charge is 8 cm. So it asks us to draw the position of three charges. So first, let's draw the positive 5 microcoulomb charge over here, and then a 2 microcoulomb charge over here. And then there's a negative microcoulomb charge in between them, so in the middle. And then the question asks us to show the forces acting on the negative 4 microcoulomb charge. So since this one is a negative charge, this one is a positive charge, they are opposite sign, so they will experience an attractive force. So negative 4 charge will be attracted to the left side because of positive 5. And then negative 4 will also be attracted to the right side because of the positive 2 charge over here. So let's draw all the forces. Okay, so don't forget that you have to draw like a free body diagram. You make the charge over here, and then the force should be coming outside from the charges instead of going like this from not connecting. It should be connected. Okay, let's move on to question 2. It asks us to calculate the distance of the 5 microcoulomb charge from the negative 4 microcoulomb charge where the net force on negative 4 microcoulomb charge is 0. So it basically asks us about the distance over here if the net force is 0. The net force is 0 meaning that the force over here is the same as the force over here because they are in opposite direction, they will cancel one another out. Okay, so first let's label it A, B, C to better identify it later. And then we write out label the force. Here I write out FBA. For me, it means on B by A. The force is acting on B by A. Of course, you can write it as FAB, where it means by A on B. It's just personal preference. It depends on you how you want to write it. So for me, it's on B by A, FBA, and then here FBC on B acting on B by C. Okay, let's make it smaller, and then we start the calculation. FBC minus FBA equals to 0. Just like I said earlier, the net force will be 0. So why is there a negative over here? It's the same because there is different or opposite direction in two forces. So we put a negative sign over here. Now we're just assuming that the right side is positive. Of course, you can, if you want to, you can make the left side positive. But now I'm using right side as positive, so I make FBC equals to is positive, and then minus FBA where it will be negative because it's left. So move it to the other side, and then now we want to find the equation for the force. So equation force is equals to K Q1 Q2 over R squared, where R squared means the distance between Q1 and Q2, so the distance between the two charges. So if you want to calculate the FBC, we have to know the distance, and then the charge we already know, and then K is the constant. You can refer the right upper side if you forgot about the constant and what is the value of micro. So okay, back FBC, we have to find the distance, but we don't know, right? And we are looking for it, so we just label it first. The information from the question, the separation between 5 microcoulomb charge and 2 microcoulomb charge is 8 cm. So 8 cm is 0.08 meter. And then we label here, we assume here is R, we give it a variable. And then here it's because 0.08 minus R, so this one is 0.08 minus R meter over here. So we put in the value inside. K for force FBC, it will be K QBQC over 0.08 minus R squared. Why? Because the distance between B and C is this. And then the same over here, FBA, it will be K QB QA over R squared, where the R, because the distance between them is R squared. Okay, and then you can simplify it by deleting the same value, because k over here, you can erase it, and then so you get QC equals to QC over this distance equals to QB over the distance. Okay, so when you put in the value, remember, don't put any sign, because we are now only calculating the magnitude. Why don't we have to put a sign? Because we indicate the direction at first already. We determine the direction by ourselves instead of letting the sign decide. So it will be clearer for us to do it that way. So by solving this one, you will get the answer r equals to 0.05 meter. So here will be 0.05 meter. Okay, let's move on to question 3. Sketch and find the electric field midway between 5 microcoulomb charge and 2 microcoulomb charge if the charge -4 microcoulomb charge is removed. So this one is removed. And then it one in the midway. So we made a point over here and we name it X. And then because it's midway, so it will be 0.04 meter over here, because the total is 0.08 divided by 2, 0.04. And we want to find the electric field. The equation for electric field is equals to force over Q. So what does it mean? It actually means how much force will a charge experience if we were to like put a charge over here. How much force will it feel? So if we divide by Q, means how many force will one coulomb charge experience if you were to put one coulomb charge over here. So if you were to expand the force equation, it will be k q1 q2 over r squared over q1, and we can erasing the similar value, and then we will get k q2 over r squared. It depends on you. Q2 it's just which one is causing. Oh, this one is the charge where the force is exerted by. Now let's move on to the calculation part. We can put in the value of we can put in the equation. It will be k qa over r xa squared. So the distance between x and na will be rxa and n squared. So we just follow the equation. And then why is there a negative over here? Because the electric field is acting on opposite direction. So let's say for this one, if we were to put a test charge over here, a positive test charge over here, and then what will be the force experienced by the x or the charge over here? For A, it will be moving toward the right side, because this one is positive, it will be repulsive, it will be acting toward that side. So F acting on X by A. And then for here it's the same. So the direction of electric field is actually similar to the direction of electrostatic force. So since there's a opposite direction, so there will be some one of them will be negative, right? So again, we can take the right side as positive and the left side as negative. So it will be negative for the C one, for the C. So we're putting the value inside. K will be 9 exponent 9, which is the constant, and then 5 times 5 exponent -6 will be the microcoulomb. So we don't have to put in sign over here, because we are now only calculating the magnitude. Where the direction we determine by putting the negative sign ourselves, so it will be clearer for us. So of course you can also factor out the k from here, so you can the calculation will be easier. Or even more, you can, since the distance will be the same because 0.04 meter. We can factor out those two and then putting the value into the calculator, and you get the value, the final answer. So the unit will be N per C. Actually, we can see over here the equation. It will be force. The unit of force is what? Is N, Newton. And then what is the unit for Q? It will be charge. So Newton per charge. That's why the unit is Newton per charge. Okay, let's move on to question B. So 3-point charges are located at the corners of an equilateral triangles as in the figure below. And the first question, it asks for the net electric force acting on the 7 microcoulomb charge. Okay, let's make it bigger and then we'll look at it one by one. And first, let's label it A, B, C first. So yeah, it's easier to identify them. And then since it's an equilateral triangle, we know that the side will be the same, and then the angle inside will all be 60 degree. Okay, we already have all the information. Let's move on to the question. The net electric force acting on a 7 microcoulomb charge. So 7 microcoulomb charge, so charge A over here. What will be the net force experienced by it? So we look it one by one. For A and B, it is positive and positive, so it will be repulsive force again. So A will feel a force acting toward that side. So how about A and C? It will be a positive and negative one, so it will be attracted to one another. So A will be attracted to that location. So it will be F on A by C for me, or you can want to write FCA, it's also can. And then here will be F on A by B. Okay, so how do we find the net electric force? So just like last semester, when there's a different angle, it's not on the same axis, we have to resolve them into x-axis and then y-axis. So for this one, it will be here to the right direction and then upward direction. And then for FAC, it will be right to, and then there will be a downward force also. So let's find out FAB and FAC first. So for FAB, same just like before, KQAQB over R squared. So we put in all the value. Again, we don't have to put in the sign because we just want the magnitude. So micro is exponent -6, K is 9 exponent 9. We put in the value and we get 0.504 N. So here FAB will equals to 0.504 N. Okay, now FAC, again the same thing, A and C. It's 7 and 4, and we don't want the sign, so we get 1.008 Newton. So here will be 1.008 Newton. And then now we want to resolve it into x and y. We can make a table to ease us. And then for FAB, right? This one is FAB. And then this one is FABY. Then FABX, like, okay, so now let's look at here. It's 60 degree over here, and then so here will be 60 degree too, because here is parallel to here, and then this one is a straight line, so here will be 60 degree, like in secondary school. So here will be 60 degree. So how do we find the x component of FAB? So we will want to use cos, because cos angle will be equal to adjacent over hypotenuse. Here will be the adjacent, here will be the hypotenuse, here will be the opposite. So cos theta, cos 60 degree will be equals to FABX, where is the adjacent, over FAB, where is the hypotenuse. Then we put in the value. FAB is 1.008 as we calculated earlier, and then just times over here and we'll get the answer. Oh, we get y first. Okay, x will be 0.504 cos 60, and then y component will be 0.504 sin 60, because sin will be all over h. So yeah, just like this one, times, and then you get the answer. So AC, it will be the same, just like last time. So FAC, Y component, and X component. Now here, there is a negative sign over here, because as we can see, FAC over here, it will be the Y component will be acting on downward. So like usual, we take upward as positive and then downward as negative. So we have to put a negative sign over here so we can determine the direction easily. So now we have to calculate the total. Just this one plus this one plus this one, and you get the answer 0.7560 Newton and negative 0.4365 Newton. So this actually means that the final force will be, the X component will be here, and then the Y component will be over here. So if we combine these two, the force will actually be here, acting to the right bottom side. Okay, now that we have the value of X component and Y component, we can calculate the net electric force. So the net force will be sum of Fx to the power of 2 and sum of Fy to the power of 2. So and then square root. This is just Pythagoras theorem, like the usual one. We calculate, and we put in the value, and then we calculate, we'll get 0.8730. So this one will be 0.8730 Newton. This one is the F net. And then next we have to determine the angle over here, because if we don't put any angle, it will be 0.8730. It can be pointing to any side, so we have to be specific, and then we have to mention what is the angle. So to calculate the angle, inverse tangent Fy over Fx. I know this one you should be more familiar than I. So when you are trying to calculate the angle, don't forget to put a modulus over here, because now we want to ignore the sign. It should be summation of Fy over here. Okay, it should be a negative value over here, right? But then we put a modulus so that we remove the sign, so we can just find the angle, and then later we determine the direction, and then which quadrant it should be ourselves. Put in the value, we get 30 degree, but then remember it is downward over here, so it will be 30 downward, and then we have to be even more specific, because below x-axis it can be also mean here on the negative side. So you have to be even more specific, below 30 degree below positive x-axis. So the final answer will be 0.8730 Newton, 30 degree below the positive x-axis. Let's move on to the next question. Potential at midway between -4 microcoulomb charge and 2 microcoulomb charge due to all the charges present. So it's asking for the electric potential in here, midway between -4 and 2. Yeah, over here. So what is electric potential actually means? So electric potential, it's actually used to find electric potential energy. And now you mean, oh, what is electric potential energy? Okay, for electric potential energy, we can use an analogy of spring, which I learned from Mr. Gan, that for this positive and negative charge, right, they should be experience an attractive force toward one another. So they should be moving close, and then until they touch, right? But then now we are fixing them on some distance. Like now it's 0.5 meter. So there's we are fixing them, just like we can imagine it as a spring over here. The spring should be close together. It will be the spring should be shrinking to the toward one another, but now you're like stretching them out. So this potential energy. So for spring it will be elastic potential energy, but now for charges it will be electric potential energy. So the equation will be V equals to KQ over R. So let's write it down first. KQA over RA. So again according to the equation KQB over B, KQC over RC. So we have to find, it will be, so all the charges will be affecting this point over here. So we have to consider all the charges. QA over here will be, we can factor this out, and then we want to find RA, right? RA is over here, RA, then RB is over here, and then RC is over here. RB and RC, it's easy, we can 0.5 divided by 2, it will be 0.25 over here. So RB and RC already find it. RA, we need to use Pythagoras theorem. As you can see, it's a right angle triangle over here. So a squared plus b equals to c squared, s equal to 0.433. So 0.433 over here. So we just put in the value again, but this time we need to put in the sign, because a positive charge and a negative charge, they will have different effect on the electric potential. So we have to put in the sign. Okay, let's move on to question 3. The electric potential energy of the system. So just like what I have said just now, electric potential energy, and then for electric potential energy of the system, so you will add the potential energy of all the charges in the system. So now it's 3. So we can imagine here have another spring, here there's another spring, so 3 spring in total. So there will be 3 potential energy, and then so we have to add 3 of them together. So now it will be electric potential energy. So we use a different formula, K Q1 Q2 over R12, and then Q1 Q3 over R13, Q2 Q3 over R23. What does it mean? So just like this one, the system, it will be having like three spring. So we have to consider all the spring over here. So AB over here, BC over here, and then AC over here. So we put in the value, and then we again this time we have to, for electric potential and electric potential energy, we have to consider the sign because it will affect them. And then RAB will be the equilateral triangle, so the side will be 0.5 meter. So we just put in the value and then the charge as usual, and then we calculate. Of course, you can factor out the same thing, so it will be easier to do it in your calculation. Of course, this one is not mathematically correct, but then you can do it in your calculator, so you can do calculation quicker, so you do faster in your exam. So you put in this put in all the value, and then you get U equals to negative 0.396 joule. So yes, electric potential energy can be negative. This one is electric potential energy. Done. And then let's move on to question C. So an electron enters a region of uniform electric field E, as in figure 3. So there's an electric field over here, and then the charge that is going in is an electron. So let's recap back at the formula of electric field just now. E is equal to F over Q. So what it actually means is that what is the force will one column charge experience if it were to like pass through that region or go on that position? What will be the force experienced by it? So now we want to calculate the acceleration of the electron. So acceleration, as we all know, it's related to force. We have to find the force acting on the electron. So we use the formula. The electric field will be 200, and then the charge of an electron is, it should be there should be a negative, but then again now we're just calculating the magnitude of the force. So we ignore the sign, we don't put in the sign, and then we put in the value of charge of electron will be 1.602 exponent negative 19. This one of course will be given in your formula list or in the question. So you get F is equal to, it should be E. The F will be equal to 3.204 exponent negative 17 Newton. So we want to find the acceleration. So again, using this formula, F equals to ma. So Force we already have. Mass of electron, it's a constant, so it should also be in the formula list too. Then we want to find A. So this one divide by this one will get A. So the final answer, the A will be 3.517 exponent 13. So now maybe you think, oh, shouldn't there be gravity? Gravity will also act on the electron, right? But then if you were to gravitational acceleration toward the electron, it will be 9.81, which is exponent 1 over here, and then this one is exponent 13. So it will be the acceleration due to the electric field will be much larger than acceleration due to gravity. So that's why we ignore, because there's no significant effect. So this one is the final answer. So that's it from me. My name is Chuo, and thank you Miss Farina and Mr. Gan for guiding me in this explanation. Thank you for watching. Enjoy your LEPAK session. Thank you.